Hello class, we're in lesson 6 today in chapter 5, and today we're going to be discussing length and area. We have a picture here of a baseball field, and it says here a baseball diamond is square in shape, having sides that are 90 feet long. The distance that a player has to run in going around the diamond is called its perimeter. This distance, the sum of the length of its side is 90 plus 90 plus 90, which is equal to 360. So if we were to put up a diamond here, and then just put up the shape, see if we can find that for you. And it's actually it's a square. If it's done with 90-degree angles, you'll learn that more in geometry. And in baseball, particularly, we know that the distance from home, we know this would be home plate for those of you who know baseball. Let's get rid of this up here so we can see much more clearly. So we have home plate, and we have first base, right? And we have second base. And now we have third. So the distance between home plate, let's just call it home here, is 90 feet. Okay? Now, being it's a square, all sides are equal. Now, some people may say it's a diamond, right? It's a diamond, but actually when you turn it on its side, it's a perfect square. Because, again, these are 90-degree angles, and each of these sides are equal. So that makes it a square. So there's 90 feet here, and there's 90 feet between second and third, and there's 90 feet coming all the way back home. So if a player ran perfectly from home to first, to second, to third, and back home, what would that distance be? Well, it would be the perimeter, and you would actually add all of these together, as we saw, and that would be equal to 360 feet. So let's put here the perimeter, or P, is equal to 360 feet. Now, the area enclosed in the baseball diamond, on the other hand, is the product of its length and width. The product means you multiply. So you would have to actually multiply the length and width. And in the case of a square, you're just multiplying the two sides, which are equal. So it would be 90 times 90. Okay, so area would be equal to 90 times 90. And we know that that's going to be 8,100 square feet. And that's the measurement that we use for area if the sides are measured in feet. If it were inches, it would be square inches. Now this means that the diamond could be divided into 8,100 squares, each measuring 1 foot on each side. So if you would actually take and make a measurement for every single foot, and there are 90 here, right? There's 90 feet going all the way. I'm not doing 90. I obviously don't have really the scale for that. But we also know that there will be 90 here, and we would do that. And we can create a grid. And if we created that grid, so to speak, of 90 feet, lines going 1 foot each, and there would be 90 of them, and we created a grid going this way as well, every one of these little blocks would be a square foot. Okay? So if I were to enlarge it, let's just say, and I say this is a square foot, it's 1 foot by each side, there would be 8,100 of these, because there's 90 rows, and there will be, let's say, 90 rows here, or let's say 90 columns. It's turned on its side, so I can't really say which one's a row or a column, but let's just say, for the sake of the math, that we have 90 rows going in different direction, and we would multiply that, and we would end up with 8,100 squares, each measuring 1 foot on each side. Now, the methods for finding the perimeter and area of a baseball diamond can be applied to any rectangle. It is easy to see why, if the sides of a rectangle have lengths that are integers. Let me reread that. It is easy to see why, if the sides of the rectangle have lengths that are integers. So we have an illustration here. The figure on the right, for example, show why a rectangle 3 centimeters long and 2 centimeters wide has a perimeter of 10 centimeters and an area of 6 centimeters. And if we take a look, we can see across the top. I'm going to actually draw that up here. Let me go ahead and find my tool here to make my square or my rectangle, right? And let's just divide these up. Hopefully they'll at least appear to be even. They won't necessarily be perfect, but we're just using this for illustrative purposes. Okay. Now, it's not really to scale, but let's go ahead. And when I say to scale, that this side isn't perfect, they should be perfect squares. But let's just go ahead, for the sake of doing the math, understand that we have here, this is our first unit, and these could be feet, could be inches, it could be millimeters, it could be miles. Okay, but we're just going to give it a value of 1. This is our second, and this is our third, right? And this is we're just going to add them all up. 4, 5. We're just going to count them, actually, not add them, but count them. 6, 7, 8, 9, and 10. Okay, so in this particular case, we were saying that they're centimeters. It's 3 centimeters long, right? 1, 2, 3, and it's 2 centimeters wide. So if we counted each centimeter all the way around, we would end up with 10 centimeters, and that would be the perimeter. So P would be equal to 10. Now for us to determine the area, well, we would have to multiply that 2, right? We know that there's 2 on this side, and there's a 3 up here, and what I'm saying is that they're 3 centimeters, right? So we multiply that, and the area would then be equal to 6, and we can count them inside. We say 1, 2, 3, 4, 5, and 6. Okay, so there's 6 square centimeters inside. So that's what we're looking at when we're talking about area and we're talking about perimeter. You must understand that, turning over to page 214, that the perimeter of a rectangle or any geometric figure bounded by straight line segments is the sum of the lengths of its sides. So the length of each side here were 3 and 2, so 3 plus 2 is 5 plus another 3, okay, because this is the same length as the other side. There would be 3, and then there will be 2 more, so there will be 3 plus 2 is 5, plus 3 is 8, plus 2 is 10. Okay, so we know that that's the perimeter, and the area of a rectangle is the product of its length and width, and we did that 2 times 3. So we have some examples here, and now we're going to implement our wonderful variables into this. We showed you a simple example just to explain to you the more basic concept, but now we're going to enter into some of these algebraic expressions so that we can understand how we can solve these. Now I've gone ahead and I've cleaned up our board here so we can do our first example. And our first example says, find the length and the width of this rectangle if its perimeter is 24 units. So they're giving us information, but I'm noticing that we have some variables here. So let me go ahead and draw up a rectangle here. And let me draw the rectangle that they've given us. And we're going to use the information that they've given us as well so that we can determine what the answer is. We can determine what x is. And actually by determining x, then we can determine what each sides are, the length and the width. So what are we given? Well, we're first given here x plus 3 as the length. And remember, we have 2 lengths and 2 widths, right? So we have x plus 3. And we also have x. And we call it width and length. You know, I always get caught up as which is the length, which is the width. Sometimes I think length going across, but then isn't that width? So maybe this is the length. Either or, it doesn't matter since we're multiplying. And in this particular case, we're going to now have to determine, based on the perimeter being equal to 24 units. Okay, they're just giving us units. They're not telling us if it's inches or miles or centimeters. But we do know that when you're actually trying to find, the perimeter, that you're supposed to add all these together, right? So we can certainly say, we can write, I'm going to show it two ways. I'm going to show you x plus 3 plus x plus 3. That's if we went around like we did in our first example and we just added each one up. So I started over here and said x plus 3 plus x plus 3, right? Now you'd also know that you can also write this simply as we have 2 of each. So we can write the equation simply as 2x plus 3, right? There's not x plus x, but x plus 3. And I just need to undo this. Now, so we have x plus 3. And we also know that we can simply multiply 2x, or 2 times x. So there's 2x plus 3's. There's one here. There's another one here, right? And we can say the same for x's. So 2 times x plus 3. Now notice we put the parentheses around it, okay? Because if we were to add x plus 3 to x plus 3, what would we get? Well, we would have 2 x's and we would have 2 3's, which means we would have 2x plus 6, right? And that's why it's very important to put parentheses here. Because if I simply wrote 2 times x plus 3, without the parentheses, I would not be distributing the 2 to the 3. So let's go ahead and distribute, and what do we get? Well, we would end up with 2x plus 6 plus 2x, right? Now, let me take a step back and let's note that this is equal to the perimeter, right? This is equal to the perimeter, but we know what the perimeter is. And what's the perimeter? They say the perimeter is 24. So when we were writing this expression, we know that when you add these all up, or you multiply and add, that we know they're equal to 24. So we're trying to determine what the x value is, because once we determine the x value, we would know what the length and width. We would know exactly what this is. We would put in the x value in and add to 3. In this case, we would just simply have the x value. So, when we created this equation, we're stating that 2 times x plus 3 and 2 times x is equal to 24. Now, of course, we know how to solve these, and we're already started here by multiplying and distributing the 2, and we ended up with 2x plus 6, and we know that we can now add the 2 x's together and get 4x plus 6 is equal to 24. Okay, so we simply added these two like terms. That's all we did. But now we have to apply what we've learned in our previous chapter, right? It was where we were, what we do to one side of the equation to the other, and we're going to isolate the x and we're going to solve for x. So in this case, I would subtract 6 from this side so we can isolate the x on one side. So I would have to subtract 6 from this side as well. And that would now give me 4x. And I'm just going to write it over here because the two 6's, the positive and negative 6, will be equal to 0. So we have 4x is equal to 24 plus negative 6, or we can say 24 minus 6, and that would be 18. Now we're going to end up with a little bit of an uncommon number that we're not used to dealing so much with these decimals, but this will definitely be a decimal. And a lot of times our answers will be in decimal or fractional form. So we're going to divide each side by 4. And when we divide each side by 4, we will find out that x is equal to, and we divide 18 by 4, well, we know that it goes in to 16 4 times, but we're left with 2, so we're left with 2/4, which is 4.5. And whether you leave it as a fraction or not, we're typically dealing with numbers, so we would probably want a decimal form, but you'll notice in certain sections, in certain areas, we're going to keep things in fractional form because they're giving us so many fractions, and it's best for us to deal with the fraction rather than the decimal. In this case, we just simply gave a decimal answer. So we know now that we have a length and a width that can be determined, this is now going to be equal to what? Well, it's going to be equal to 4.5, right? And that means this side as well. But over here, we would have 4.5 plus 3, and that's equal to 7.5. So our length and the width are 7.5 and 3.5. And if you plug it back into our original equation, the x value, you will find, as they show here, that that our answer is correct by checking. So checking is very important. It's important for you to make sure you got the right answer. So you plug it in and you do your little bit of math, and you'll determine whether your answer was correct. Okay. So this was the first example. We'll move on to another example in our next video.